Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amrul Hafiz bin Azhar. My text number DE220177. We are from Group 8 of Section 2 of Ordinary Differential Equation. And in this video, we will be presenting one of the question that we have already completed, which is question 1. So in this project, I will start with finishing question 4.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azami and my matrix number is DE220124. Okay, today I'm going to talk about our ordinary differential equation project, which is a assignment project. It comprises of 4 people, which is me, Muhammad Azami, DE220124. I answered for the question 1. For the question 2, which is for 1 Harid Bashir bin Shaiman, DE220200, and for the third question, which is the one that needed to do it, we contribute to Nick Muhammad Farhan Afwan bin Nick Muhammad Rizal, DE220095, and for the question 4, we give it to Muhammad Amir Hafiz bin Azhar, DE220177. Okay, so our group will be going to show the video for question 1. Question 1, we done it 2 things, which is for the manual calculation and for the MATLAB calculation. For first thing first, we're going to for the manual calculation, which is here is question number 1. For the Q1A, calculate the first order differential equation below using transformation y equals to xv. And if you remember, if you know that for the ODE first order, y equals to xv, we use it in homogeneous equation. So we got it here, x dy per dx plus 3y equals to 2x subtract with y. So here we can conclude it using homogeneous method. Okay, so here we're going to first thing first, we're going to simplify it, apply the degree of lambda, and we're going to check if the lambda is equal or not. So here we got it, homogeneous equation by degree of lambda equals to 1. So we can conclude this equation is homogeneous. So we proceed by using the homogeneous method, which is y equals to vx. We apply it to it, and then we substitute v equals to yx, and we can get the general solution, which is c here is constant. So whenever you divide it, you multiply or you plus or anything, it will still be a c, which is a constant, so no effect. That's why we're going to check it up, and here we get it y equals to 2x per 5 plus c per x to the power of 4, and here still remain c is constant. So because of this equation, this question have no condition, so this is our final value, which is the general solution, y equals to here, you can see. Okay, that's for the manual calculation. Okay, so next we're going forward for the MATLAB, for the mathematical solution, mathematical software solution. So in this case, we're using the MATLAB because Utension provided MATLAB for free with the license given. So hold on a second, we're going to open my MATLAB. Here is the mathematical software MATLAB. You can see we enter at the editor, clear all sims y x, and ODE equals to differentiate y x. We just enter the equation from the question. Okay, let's try. Okay, our MATLAB is online. So as you can see here, I already have the command, which is I entered from here, where you can see the equation is similar, which is not this one, this one. We already simplified. so x already go to the right side and 3y also, and here is the same as the below, which is dy dx equals to 2x negative 4y per with x. So if we run it, yes, if we run it, it will conclude here. Question 1a, and there we go. We will enter the ODEX, which is, first thing first, we acknowledge what is ODEX, which is differential yx, that is, and then we get the solution for the ODE, which is, if we summarize from our manual calculation, it's also the same, which is 2 multiplied with x divided by 5 plus with constant divided by x to the power of 4. So from here we can get the same answer as the manual calculation. So here I can conclude it is right. Alright, that's all from me, thank you.
Okay, so moving on. So question 1b give us a first order differential equation in the form of exactness, which is m dx plus n dy equals to 0. And the first question asks us to identify the exactness of the differential equation, and the second question asks us to calculate the particular solution with initial condition y 0 equals to 1. So moving on to the solution. For the first part of the question B, we need to identify the exactness. So we need to make sure that the partial differentiation of m over y is equals to the partial differentiation of n over x. So first we need to identify the m and also n. So the m is equals to 3x to the power of 2, y to the power of 2, minus 5x to the power of 4, and the n is equals to y plus 3x to the power of 3, y to the power of 2. And then we need to do the partial differentiation of m over y and also n over x, and then we can see that both of the partial differentiation yields 9x to the power of 2, y to the power of 2. Since both the equation is equals to each other, so this means that it is an exact ODE, or it can be solved using the exact method. And then moving on to the second part, we need to find the particular solution using the initial condition y 0 equals to 1, which means that the y is equals to 1 and the x is equals to 0. So first we need to discover ixy equals to integrate m dx plus fy. So from this equation we could see that it is equals to x to the power of 3 over 3 plus 3xy to the power of 2 plus 5x plus fy, and then discover ixy equals to integrate n dy plus dx, which is equals to 3xy to the power of 2 plus 3y to the power of 2 plus 3y plus dx. And then we need to combine both the equation without any repetition of operation or terms. So we could see that the general solution is xy equals to x to the power of 3 over 3 plus 3xy to the power of 2 plus 3y to the power of 2 plus 3y plus 5x equals to c. So in order to obtain the c, we need to insert the initial condition, which is y equals to 1 and x is equals to 0. After inserting the values, we could see that c is equals to 6. Therefore, the general solution will be ixy equals to x to the power of 3 over 3 plus 3xy to the power of 2 plus 3y to the power of 2 plus 3y plus 5x minus 6 equals to 0. Okay, so moving on to the comparison between using MATLAB to the manual calculation. So for the coding of question 1b, first we need to insert sims yx and then insert the ordinary differential equation from the question and then set it as ODE, and then we need to use this solve to obtain the general solution of the ODE, and then set it as y sol x, and then insert the initial condition and set it as con, and then we need to find the particular solution using the solve or DE cont and then set it as solve. And then after we run the coding, okay, so as you can see, the general solution or YSOL, the answer from MATLAB is different from the manual calculation. However, the actual answer is very similar. We need to change the manual calculation equation to match the one from MATLAB. So this is the transformation from the manual calculation to the MATLAB. So after transforming the manual calculation, we could see that the answer is actually the same as MATLAB. And then moving on to the initial condition, the particular solution, we could see that the answer is different, because using the equation from MATLAB, we could see that and then inserting the value of x and y, we could see that the c is equals to -6, while our calculation obtains c as equals to 6. This could be due to the transforming of the manual calculation to MATLAB, since the characteristic of c, when c is multiplied or divided by any number, it is still equals to c. So this could change the actual value of the c. Because of that, the answer for the particular solution is slightly different. Thank you.